use today to treat the basics of the physics practical that you really need to understand. So, and I want you to pay rapt attention. So, um, we have different aspects and focus for the physics practical. But before I move on, I want you to tell me what are the basic aspects of physics that you know of? What are the basic aspects of physics that you know of? Yes, can you hear me?
Yes,
Can you
ma'am.
hear me now?
Yes,
Can you
I
hear
can
me?
hear you.
Hello, what are the basic aspects of physics that we have?
Mechanics,
Mechanics, yes.
optics,
mechanics,
Mechanics,
and electricity.
electricity, optics and waves, nuclear
Motion.
physics, or
different physics,
Thermodynamics.
thermodynamics,
quantum physics.
quantum physics. So you have mentioned the basics ones. The basic ones I want you to mention. The first one is electricity. The first one is electricity, then waves and optics. So after that, we have thermometry, that is measurement of heat and temperature. And of course, someone already mentioned mechanics. So those are the aspects that your physics practical usually covers. Usually we have questions, and under electricity is divided into two broad parts. What are those two parts? Yes, the two types of currents that we have. Are you there?
Sir, please, could you repeat yourself?
What what are the two types of electric currents that we have?
Direct current and alternating current.
Very good. So what's the source of alternating current? What's the source of direct current? Yes. What's the source of alternating current? What's the source of direct current? Please, are you there? Can you hear me? Hello?
Yes, sir. Yes, sir. We're hearing you.
Yes, please talk. If you miss it, I won't flog you. But I need you to really talk. This is practical session. This is practical session.
Source for direct currents are like batteries.
Source of direct current, you talk about batteries, cells. That's very good. Source of direct current. So all about source of alternating current.
Transformers.
Inverters.
Yes. So the main
Sir,
supply.
what is the relationship between the slip
Hey,
and
hey,
split rings with AC and DC?
Faith, take it easy. Are you here? Sister Faith, are you here? Are you with us?
Yes, sir.
The name Sister Faith. Okay, do we have Sister Faith here? Okay,
Sir?
so all right. Okay, so what is the source of direct current? Source of direct current, yes.
Batteries.
Batteries, cells. So everyone of you see the cell and battery before. Hmm. I'm not getting response. This is practical class. You cannot stay muted.
Sir, you were
You
not
have to be
available.
responding.
So I can't hear
You
you.
can't hear me.
Sir, we're struggling to hear you.
You are struggling to-
Yes.
We can hear now.
Okay, so you can hear me now. Is that not?
It is.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay. So what I'm asking now is that what's the source of direct current? What's the source of direct current?
Batteries. Batteries, solar panels.
So what's the difference between a battery and a cell? What's the difference between a battery and a cell? What's the difference between
Connection of two or more cells.
a combination of two or more cells? Is that not?
Yes, sir.
Okay, so batteries, the EMF of a cell is rated in what unit? The EMF of a cell is rated in what unit? The EMF of a cell is rated in what unit?
In volts.
In volts. So give me examples of rating of EMF of a cell.
V equals to IT.
No, examples of rating, values of cell EMFs.
Okay. Power
We have
equals
1.5 volts. We have
Yes,
1.5 volts. Oh, I think someone's speaker is on, right?
So
We can hear you, sir.
1.5, 1.2 volts.
Have you seen 1.2 volts battery before?
No, sir.
So 1.5 volts is the common one, and all these Duracell, two-door, Tiger battery. Have you seen something like that before?
Yes, I have.
Yes, sir.
So that's talking about um source of direct current. So what's the source of alternating current?
Inverters.
So the main supply of the house is an alternating current. What did I say?
The main supply of the house is an alternating
The
current.
main supply of a house is an alternating current.
So they will not ask you to use main supply to do practical. What did I say?
They will not
They won't
ask
ask
us to
you
use
main.
main supply to be practical.
All right. So what the user has to do is to make use of DC source. So is there a difference between DC source and AC source? Is there a difference between the two?
Yes, sir.
Yes, sir.
Okay, so what's the difference between AC and DC source?
The difference is that one is using a high voltage, while one is using a low voltage.
So which one is using high voltage, which one is using low voltage?
AC.
Which one is using high voltage, which one is using low voltage?
AC is using high voltage.
So what's the voltage of the main supply? The supply in the house, what's the average voltage?
1.5 volts.
Voltage in the house on your appliances, your pressing iron, your TV, what's the rating, the voltage
Some
on them?
50, like bulb is 60 watts.
220.
120 watts.
220 volts, 240 volts. Can you relate with what I'm saying at
220.
all? Who cannot relate with? Okay.
Yes,
Is
yes.
there anyone who cannot relate with what I'm saying?
No, sir.
All right. Now for DC, so give me the example of voltage for DC source or DC sources.
1.5.
1.5 volts.
1.7.
180.
Yeah. 180 volts is not DCO. 180 volts is very high. Are you with me? 180 is main source. Is that taking 12 volts, 13 volts? So those ones are the rating for direct current. Is that taking?
Yes, sir.
Now I'm sharing a slide. Can you see the slide I'm sharing?
Yes, sir.
Yes,
How
sir.
many types of, now how many types of circuit can you see in what I'm sharing?
3.
3.
So number one is called what?
Short circuit.
Short circuit.
Number two is called what?
Closed circuit.
Close.
And number three is what?
Open
Open
circuit.
circuit.
Certain.
So from what you are seeing, what's the difference between closed circuit and open circuit from what you are seeing?
In closed
Close circuit, the
circuits,
bulb.
the switch is on. While in open circuit, the switch is off.
All right. Now, in this place, the switch is more modern. Those red and green buttons, you can see them on the open or closed circuit. So how many of you have seen the typical switch in the laboratory before? How many of you know what we call switch?
Yes, sir.
Okay, you know it. So then there are times that some of you don't bother using switch. You just connect wire to wire. When you remove wire, you put it back. Then the circuit is closed. When you disconnect the wire, the circuit is open. Did you get that?
Yes, sir.
So then at times they will ask you, depending on how equipped your practical lab is, at times they will just ask you to put the wire, use sellotape to put the positive pole, one wire or connecting lead on the positive pole and put another on the negative pole, and that's how you close and open the circuit. But you are supposed to be provided with a switch. We will talk more on that. Now, the next question is, what is the source of electric power in this circuit you are looking at? What's the electric source of power there? What's the source of the electric
Battery.
power? The battery. You can see the battery. So the battery has how many terminals?
2 terminals.
Name them.
The positive and the negative terminal.
The what?
The positive and negative.
Very good. So current leaves from which of the terminals? Does current leaves? Conventional current leaves from which of the terminals?
The positive terminal.
The positive terminals.
Enter
Okay,
through the positive and leave through the negative.
very good. Now, when you want to, what instrument do we use in measuring the EMF of a cell or voltage? What instrument do we use?
Maybe the voltmeter.
Maybe care. It's not maybe. So we use the voltmeter. Then there is an instrument that can be used to measure both voltage, electric current, resistance. What's the name of that instrument?
Ammeter.
So that's not ammeter. That we use ammeter for measuring.
Galvanometer.
What did you say?
Galvanometer.
Galvanometer.
No, we use the instrument to measure. We can use it to measure electric current. We can use it to measure voltage. We can use it to measure resistance. So what's the name of that instrument?
Galvanometer.
So that is what we call multimeter. What did I call it?
Multimeter.
Multimeter. So now this is where I'm going with this diagram. So you can differentiate between open and closed circuit now. Is that not?
Yes, sir.
All
Yes,
right.
sir.
Now, okay. So you can distinguish between the positive and in real life. How do you distinguish between the positive and the negative pole of a battery or of a cell in real life? How do you distinguish between the two?
The turning on of light of the bulb.
I mean, if you are given a cell or you are given a battery, how do you know the positive pole different from the negative pole?
Okay. I think the negative one has a smooth surface, while the positive has a hard surface on it.
Now, have you ever imagined human being standing up? Are you with me?
Yes, sir.
Yes, sir.
Yes, sir.
Now, if a human being is standing up, what part of human being is up? The
Huh?
The head.
It's running.
head, the head. So the cell also have a head. So that head is the positive terminal. Shall I say that again?
No, sir.
No, sir.
Yes, sir.
So the battery looks something like this. Can you relate with that?
Yes,
Yes,
sir.
sir.
Yes, sir.
So this upper part is the positive pole. This other part is the negative pole. Because if you cannot recognize it, if you don't connect it well, when you are given a circuit diagram and you could not connect it well, your meter can be reading negative if you are given a digital meter. But if you are giving analog, instead of the indicator to go up, the indicator may be going backward if you don't connect it well. So if you have such an experience in which the indicator on an analog meter looks like this. An analog meter looks like this. How many of you have seen something like this before? How many of you have seen voltmeter, ammeter that looks like what I just did?
You never see.
You've not seen.
Sir, the one I've seen is not like this.
So you've not seen analog voltmeter, ammeter that have 1, 2, 3 on it, and the end, like the end of a clock, is moving.
Oh,
The one I saw has calibration.
I mean, you've
I've
not seen something like
I have,
this for you.
Saya, but it's square.
for voltmeter, W is V at the middle.
That the indicator will be going up and down like this,
Yes.
like the end of a
Yes, sir.
clock.
Osen.
You see, you can relate to
Yes,
it
sir.
now.
Yes, sir.
Yes,
So
sir.
that's what we call the analog meter. It may be ammeter, it may be voltmeter. Is that taking? Okay.
Yes, sir.
Have you seen
Sir, please repeat.
the
So your
factor
voice
before?
is Jimo.
My voice is what?
It's not
Jim.
clear.
Again.
My voice is not clear.
Yes, sir.
Tim, you're far from your speaker.
Can you hear me now? Can you hear me?
It's still dim, sir.
Yes, sir. But I think
Tim,
you're
you're
talking
far
from a
from your
far
speaker.
distance.
And my speaker is as close to my mouth as anything. Okay, let me change location then. Let me change.
He's trying to mute your mic, everybody.
Okay. So any improvement now? Any improvement?
Yes, sir. Perfect.
It's better now.
It's better now. Okay. Okay. So I was asking that have you seen an analog ammeter before? Have you seen a
Yes, sir.
protractor before? Protractor. You have
Yes,
not
sir.
seen a protractor
Yes,
before.
sir.
Okay. Now a protractor is an example of analog meter. A protractor, a meter read.
Yes,
That's
sir.
it. All right. Now the clock on your phone, those clocks that used to read 1.01 p.m., 2.05 p.m., 3.51 p.m. Can you hear what I'm saying at all?
No, sir.
You can't hear what
And your voice has become unclear again.
I'm saying. Okay, I think everybody should mute for now. Mute for now. Let's see. Everybody should mute for now. Let's see. Everyone should mute. Someone is see.
Sir, could you type
If
what
that
you're saying? We can't hear you properly.
everyone should mute for now.
Okay, sir.
Okay. So respond if you are hearing me clearly. Let me know what's happening now.
Okay, that's much better, sir.
Yeah, it's better now.
Oh, so I think it's someone that is causing that. So somebody you responded with a voice now. Are you with me?
Yes, sir.
Yes, good. So please remain unmuted. I think your mic is doing you are doing a good job there. Is that taking?
I can
Yes,
hear
sir.
you
No, that
clearly, sir.
person. Okay. So all right. I think we've been able to mute the noise maker. All right. So are we together now?
Yes, sir.
Yes,
Yes,
sir.
sir.
So that there are some meters. I want to explain digital now. Digital meter. Something like this. That when you look at the dashboard, you just see 108. Have you seen something like this before? Maybe wristwatch or something. Have you seen something like this before?
Yes,
Yes,
sir.
sir.
Yes, sir.
That's what we call digital. So we have digital meters. That's what we call multimeter. Some of these things I'll still show you their diagrams so that you can relate well with them. Is that taken?
Yes, sir.
So for electricity, you must familiarize yourself with Ohm's law. So what's Ohm's law? Are you with me? What's Ohm's law? Yes, anyone? What's Ohm's law?
It is the fundamental principle that describes the relationship between both circuit and resistance in an electric circuit.
Okay, I GTP that you use anyway. So please don't use Chat GTP. Don't be tempted to go to exam hall with your phone. If you use Chat GTP, I've conducted the exam and I was able to locate candidate that use Chat GTP and the rest for my exam, and of course. So please don't be tempted to use Chat GTP. Don't be tempted to take phones for exam. Concentrate, study hard, please. There are 1001 way for the examiner to know that you took in your phone and you're using ChatGTP to explain physics concepts. ChatGTP, there are some concepts that could be mixed up. In fact, the way you presented it, I'm suspicious anyway. So Ohm's law states that provided that physical constants, physical variables like temperature are kept constant, the current flowing between the ends of the wire is directly proportional to the potential difference. Can anyone relate with what I just said?
Sir, please come again.
Uh-huh. So these are basic things you need to really be familiar with. So have you seen Ohm's law on my slide?
Yes, sir.
Yes, someone should please switch.
Law states that the electric
Let's say that the
metallic
electric current.
conductor is proportional to the potential difference applied provided that temperature and other physical factors remain constant.
So that's the major law. One more time, it's a major law that guides electricity questions. Yes, please read one more time.
Ohm's law states that the electric current in a given metallic conductor is directly proportional to the potential difference applied provided that temperature and other physical factors remain constant.
Okay, so I'll give you 2 seconds, and no, 2 seconds is too small. 2 minutes to practice and read it. Then I'll now ask somebody, 3 people to state it for us. Is that all right?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right, your time starts now. Okay, is that set? Are you ready?
Yes, sir.
All right, so the first person, Ohm's law, 1 to go.
It states that the electric current in a given metallic conductor is directly proportional to the potential difference applied, provided that temperature and other physical factors are kept constant.
That's very good. Second person, second person. Ah, yeah, second person, Ohm's law.
Ohm's law states that the electric current present in a metallic conductor is directly proportional to the potential difference applied, provided that temperature and all other physical factors are kept constant.
Very good, very good. One more.
Okay. Ohm's law states that the electric current in a given metallic conductor is directly proportional to the potential difference applied, provided that temperature and all other physical factors remain constant.
Very good, very good, very good. Thank you. So from there, it means that V is proportional to I, and from there we have V equals to IR. So if you look at slide 5, can you see slide 5? Can you see
Yes, sir.
slide 5? Good. So on slide 5, we have IV characteristics. IV, I for current, V for potential difference for different materials. So you will see that there is the one on the left hand side is a straight line passing through the origin. Do you notice that?
Yes, sir.
All right. So a straight line passing through the origin, that shows that that graph represents Ohm's law. But if you look at the other side, discover that the third one passes through the origin, but it's a curve. Do you notice that?
Yes, sir.
Yes, sir.
Very good. So those two, they are for, this one is for semiconductor, this one is for filament. So they are non-ohmic conductors. That is, they do not behave according to what Ohm's law says, that V is directly proportional to I. So now you saw the picture I showed you. Now in this place, can you see my slide? Can you see closed circuit?
Yes, sir.
Yes, sir.
Can you see that yellow bulb?
Yes, sir.
Yes, sir.
Good. So that yellow bulb is what we call load, L-O-A-D. What do you call the yellow bulb?
Load.
Load.
Yes, we call it load. So load can be, most times load are resistors. Most times loads are what?
Resistance.
Yes, they are resistors. So in any circuit, when you be given question on electricity, nobody will draw bulb or draw cell. They won't draw it. They will only give you circuit symbols. They will only give you what?
Circuit
Symbol.
symbol.
So if you look at the first symbol on my slide, that's what we call connecting lead. Connecting lead is all those tiny, tiny conducting wires. Do you know the conducting wires? The wire for your phone charger. Are you with me?
Yes,
Yes,
sir.
sir.
So
Yes, sir.
that's an example of connecting lead. It connects the adapter or the plug to your phone charging port. Can you relate with that?
Yes, sir.
So that's an
Yes,
example
sir.
of what?
Connecting wire.
Connecting lead.
Connecting lead. Very good. Now, on this, what's the second item on the
Cell.
cell? Now, do you notice that for that cell symbol, one vertical line is longer than the other?
Yes,
Yes, sir.
sir.
So which one is the positive? Which one is the negative?
The long one is the positive.
The shorter one is the what?
The negative.
Is the negative one. Is that taken? So,
Yes,
like
sir.
I said, in your practical work, they will not draw Duracell or Tudor or Tiger battery for you. They will just give you circuit symbol, circuit diagram. So you are the one to interpret what you are giving. Is that taking?
Yes, sir.
Yes, sir.
So can I move to the next one? What's the next one?
Battery of cell.
So what's the battery of cells?
So I can see your screen.
You can't see my screen.
Connection.
Yes, sir.
I can see your screen, sir. Maybe
Okay.
it's network.
So you have to log out and log in again.
Okay,
Okay.
sir.
So battery of cells, what does that mean? Battery of cells. So it means in that circuit, you are using more than one cell. You are using more than one Tiger battery. What we usually call battery is a cell. That battery, that Tiger, something that you call Tiger battery, one is a cell. So by the time, if they are asking to supply 3 volts, can you hear me?
Yes,
Yes, sir.
sir.
Yes, sir.
If they ask to
Yes,
supply,
sir.
they ask to supply 3 volts. So you may need to use sellotape to join two 1.5 volt cells to make a 3 volt battery. Should I say that again?
No, sir.
All right. So so in that case, the symbol may be like for a cell, It can also be a symbol for battery of cells. And pay attention to the positive and the negative terminals. Very important. So what's the next component in the
Sadly, must the batteries be more than two so that electricity will be supplied?
Yes, batteries of cells can be more than two, depending on what they ask you in the question. In the question, they will tell you the rating. If it is 1.5 volt, your supervisor, exam supervisor, your physics tutor will have provided 1. But if it is 3 volt or 4.5 volts, they will provide you with 2 or 3. So if your lab is standard, we have component holders for cells that you can slot them in as if you are trying to slot them into the back of a wall clock. But if it's not a standard laboratory, are just managing things, now it will put a positive to the back of a negative. Then you now use sellotape to tie them together to ensure tight connection. Shall I say that again?
No, sir.
All right. So with that, you can have battery of cells. Is that taken?
Yes, sir.
Thank you. So what's the next one? Fixed what?
Resistor.
Resistor.
Yes, resistors, they are small, tiny components. Some of you have seen them before, some of you have not seen them. I'll still show you some of these pictures, or maybe I'll show you video in one of our classes to drive home some of these points. But you really need to familiarize yourself with these circuit symbols. In the practical, the diagram they will give you will be circuit symbol. So the next one is power supply. I've spoken about power supply, is that not? Hey, have I spoken
Yes,
about
sir.
power supply?
Yes, you have.
So what are the two basic types that I spoke about?
AC and DC.
Very good. Alternating voltage, direct voltage. So now the next one, the next two are very important. The next two are very important. We have the junction of conductors. Then we have crossing conductors. They are not the same. Junction of conductors means that you are tying naked wires together. That's the meaning of junction of conductors. Crossing conductors means that one line is passing over another line without connecting naked wires. Should I say that again?
Yes, please.
Now, when you connect two naked wires together, that's a junction. Does that ring any bell?
Yes, sir.
Now,
Yes,
but
sir.
good. If you are placing a wire on another wire, but you didn't open them up and tie them together, that one is just crossing conductors. Is that taken?
No,
Yes,
sir,
sir.
do you mean naked one or one that is insulated?
Of course, insulated, the difference between naked means that you have cut away the insulation, the rubber that is insulating it. That's the meaning of naked. Have I answered your question?
Yes, sir, I do. You do. You
Good.
have. I want to know if the naked that crosses it is it the same? Is it the negative one that will cross it?
No, for wire, there is no, for this level, there is no negative wire or positive wire. The most important thing is that immediately you can just make sure that all the wire you are using, they are the same type. Don't use yellow, blue, green of different types. No, if all the wires they gave you, they are red and black, make sure that's what you use for all your connections. So, but the issue of negative, positive, neutral, life and art does not affect DC practicals. Did I get your question?
Yes, sir.
Good. So what is important here is that if you are coming from the positive terminal of the cell, then continue using wire to connect your components and end at the negative terminal. So if there is any mistake, you will see it on any of your meters. Your meter will be going anti-clockwise instead of going clockwise. So by that, you will have known that I must have made a mistake in this connection. Maybe you are where you're put positive, you have put negative. So just go there and adjust. Is that taken?
Yes, sir.
All right. Now, filament lamp. Then the next thing is voltmeter. Can you see the symbol for voltmeter?
Yes, sir.
Yes,
Good.
sir.
So this symbol is very important. Most of the time, they will ask you to connect voltmeter. Okay, as the person has just okay. Please, the person should stop. I think he's Jemezu. Are you the one? Okay, I think we are fine now, right? Am I the only one hearing the echo? Okay, can we continue now?
Yes, we can, sir.
Very good. So now the next thing, so you need to pay attention to that symbol of voltmeter. So usually they will ask you to connect voltmeter in parallel to a resistor because they want you to read the potential difference drop. The potential difference drop is what they want you to read. Now, can you see the circuit I'm showing you here?
Yes, sir.
Yes, sir.
Okay. For the circuit that is below, tell me the components you could see in the circuit that is below. What are the components you could see?
I can see batteries of cell.
Very good.
I
Yes.
can see volt and ammeter.
You can see voltmeter and ammeter.
Resistor.
So the resistor is where they wrote metallic conductor. Can you see that?
Yes, sir.
Now, I want to ask everybody by attention. At least I've gotten one of our guys is really paying attention and responding swiftly. Yes, he has been my guy for our previous class. That's very good. So I want one of those that is paying attention to answer this question. What terminal of the battery of cell is the ammeter connected to? The ammeter is connected to what terminal of the battery of cells? A lady. I want a lady to answer.
The positive.
The first what?
The positive terminal.
Very good. That's what I'm looking for. It's positive terminal because so you connect the ammeter to the battery of cell or to the cell in series. So that's serial connection. That's what?
Serial connection.
Very good. But the voltmeter and the resistor, can you see the voltmeter and the resistor in the circuit diagram?
Yes,
Can you
sir.
see that?
Yes,
So that
sir.
is what we call parallel connection. The voltmeter is connected in parallel to the resistor. So they will use the voltmeter to measure the potential difference between the ends of the resistor, between the ends of the metallic conductor. Does that make any sense?
Yes, sir.
Thank you. Now, let's go to the circuit diagram above. Are you with me?
Yes, sir.
Yes, sir.
Now, do you see the thin blue lines? The thin blue lines is representing what component? Thin blue lines is representing what component? Yes, the thin blue
Connection
lines
box.
is representing
Automotive box.
the thin blue line is representing a cell. What did I call it?
A
A
cell.
cell.
So that capital E stands for what?
EMF.
Do EMF of the cell. Capital E stands for EMF of the cell, and small r stands for what?
Internal resistance.
No resistance.
Internal resistance. So very important point. So voltmeter, I mentioned voltmeter, ammeter, then switch. So the way this switch is being drawn, is it open or closed?
Open.
Open.
Open. So
Oh,
those are the terms you should be expecting. So variable resistor, can you see the symbol for variable resistor?
Yes, sir.
Pay attention. Variable resistor. What's another name for variable resistor? Another name for variable resistor.
Standard.
No. So another name for variable resistor. Can we move on now? All right. So what's it? I thought that thing was okay. Please, everybody should mute. Let's see where everyone should mute. Let's see where the problem is. Okay. All right. So another name for variable resistor is rheostat. So please pay attention to that. We'll still check into some of these things. So the next thing I want to quickly point your attention to is factors that affect the resistance of a cell. What are the factors that affect the resistance of a cell?
Length of wire.
Length of wire. What relationship between resistance of a wire and length of the wire? What relationship?
inverse.
Is it inverse?
Is inverse.
Are you sure? Relationship between resistance and length of the wire. Resistance of the wire and length of the wire. So the longer the wire, the more the resistance. So it is direct proportionality. Is that taken?
Yes, sir.
Yes, sir.
So R is proportional to L. So the longer the wire, the more the resistance. Shall I say that again?
Yes, sir.
The longer the wire, the more the resistance. The shorter the wire, the lesser the resistance. Shall I say that again?
No, sir.
No, sir.
Okay. So how about resistance and area? Relationship between cross-sectional area of a wire and resistance.
So please, can you repeat those things you said before? The factors that affect.
Have you picked that?
We are not hearing you.
Okay. Can you hear me now?
Yes.
Yes, sir. Loud and clear.
Okay. So as she picked that, the factors that affect resistance of a metallic conductor Okay, can we move on then?
Yes, we can.
So you
All
said
right.
you said the shorter the wire, the more what?
The longer the wire, the more the resistance. The longer the wire, the more the resistance. So resistance increases with increase in length. Have you picked that?
So the shorter the wire, the less the resistance.
The shorter the wire, the lesser the resistance. Is that noted?
Yes, sir.
Yes, sir. Thank you, sir.
Yes, sir.
Okay. So the next one is cross-sectional area of the wire. So the thicker the wire, the more the cross-sectional area, the lesser the resistance. Should I say that again?
No, sir.
Yes,
So
sir.
the thicker the wire, the lesser the resistance. Should I say that again?
No, sir.
Okay. So resistance increases with decrease in cross-sectional area. Resistance increases with decrease in cross-sectional area. Resistance decreases with increase in cross-sectional area. So the thicker the wire, the lesser the resistance. Shall I say that again?
Yes, sir.
So
Yes, sir.
the thicker the wire, the lesser the resistance. That's why they use thick wire for all those main supply, and they use small wire for the phones, so that they will not conduct too much. The voltage can be very small. Is that ticking?
Yes, sir.
All right. So resistance also increases with increase in temperature. Resistance also increases with increase in temperature. Shall I say that again?
Yes, sir.
Resistance increases with increase in temperature. Shall I say that again?
No,
It's
sir.
okay, sir.
Okay. So resistance depends on temperature. Resistance of a metallic conductor increases with increase in temperature. And of course, the type of the wire is also there. Silver is the best metallic conductor, followed by copper, iron, and the rest. Is that taken?
Yes, sir.
Yes, sir.
Very good. Now, something very important, very important that you need to pay attention to. Now, before I give you, we are going to do exercise. You plot a graph and you will ask questions, and we try and make it as well organized as possible, so that when we get readings, what do we do with them? All right. So the oh, okay. So who's reading the introduction?
Physics practical.
Physics practical test comprises of three questions. Candidates will be required to answer two in two whole number, 3/4 hours. It is awarded 50 marks, which is 50 out of the total score of 160 marks for paper 1. 2 50 marks, 2 60 marks, and 3 50 marks.
Thank you. So what this is telling us is that if you can do very well in your practical, it means that out of 160 marks, you have had almost 1/3 of your total score. So most of the time, practical used to be like a bonus. So any candidate that is serious with practical have already cleared almost 1/3 of the whole marks for the physics SSC. So it's 50 marks. You're answering 2 questions out of 3, and you have about 2 hours, 45 minutes to answer the 2. So that means practical like bonus if you really pay attention to what is essential. So that makes this interesting package on the DTW platform. All right. So before slide 2, someone should read slide 3, the last slide.
Experimental procedure using apparatus.
Yes.
Measurement is considered accurate.
Experimental procedure using apparatus. Even if a measurement is precise and also proceed and produces the same results, it may not be accurate because every
You should
reading
start
may have the
with-
same error.
No, I think you should start with, I want you to read the last slide first. The last slide. Start with the last slide.
Accuracy. A
Yes.
measurement is considered to be accurate if the value obtained is close to the true value. Precision. The level of precision of a measurement is very high if several measurements of a quantity are all very similar. If they are spread around the room, they are less precise. Precision are reflected in how the results are recorded. 15 meter means nearest meter, while 15.0 meter means nearest 0.1 meter, which is more precise.
Thank you. Now, when we say accuracy, we are saying that how close is your value to the true value? That's the meaning of accuracy. So when you are doing practical, your physics tutor will also submit a list of values. So how close your values are, your readings are to what your physics tutor submit, and what is conventionally acceptable is the measure of accuracy. Now, it's different from precision. Precision is saying that you measure one thing 3 times. Those 3 answers, are they close to each other? Now, are you with me?
Yes, sir.
I want to give you an exercise. I want 3 persons to tell me what the time is now.
9 minutes past.
Over here is 9 minutes past 8.
So 809, 1. Second person,
9 minutes past 8.
8 what?
809.
809. The third person,
809.
are you sure everybody is 809? I thought somebody mentioned 810, 810.
8:14.
All right. Now, did you say 814? Okay. Can you hear me, please?
Yes,
Can you hear
I
me?
can hear you.
Yes,
Now,
sir.
I asked, I said, what's the time now?
I don't understand what is happening. No.
But you don't understand what's happening, but can you see the slide?
I don't understand the answers they're getting. How are they getting those answers?
The slide. Are you seeing the slide?
Your time.
Hey,
Yes, I can see the slide.
you can see the slide. I think is that already?
No,
No,
sir.
this is Faith.
Please stay unmuted. Faith, stay unmuted. Are you there?
Okay, sir.
Are you there?
Sir, can you hear me?
Yes. You have background noise. I'm trying to get your attention, but can you, I can hear you. We can hear you. Are you
Sir,
there?
can you hear me?
Okay. I just need to continue. I'm not sure you can hear us clearly with that background noise. Okay.
So
Now
let
we
us
move on now. She should mute. Please mute your mic. Please. Thank you. Yes, with that background noise, I'm not too sure you could hear us clearly enough. All right. Now, I said I'm trying to explain precision. You are using an instrument to measure the same time, but what are the answers you are getting? So someone said 809, another person said 809, another person said 809, another person said 814. Am I right?
Yes, sir.
Good. So 809, 809, 809, that's precision. But 809, 809, 814, that 814 is out of it. So the level of precision has dropped. Mainly if you so in an exam, in a practical session, that 814, you won't use it. You will only use values around 809, 810, thereabout. If not, your result will not be precise. Who has not picked what I'm saying?
Move on, sir.
All right. So that's for precision. So accuracy means how close. Now, someone should now read the second slide now, the middle slide.
Experimental procedure, sir.
Yes.
Experimental procedure using apparatus. Even if a measurement is precise and always produces the same result and always produces the same result, it may not be accurate because every reading may be the same, may have the same error.
Good. Now, the time now is 8, that's 8:13. Are you with me?
Yes, sir.
Yes, sir.
Let's now assume that my own clock is fast, or is faster by 5 minutes rather. So it will be 8:18 instead of 8:13. Is that not?
It is.
Now, in 1 hour time, my own reading is 8:18. Now, in 1 hour time, what will it be?
9:18.
9:18. In another 1 hour time, what will it be?
10:18.
10:18.
In another 1 hour time, what will it be?
11:18.
So is my clock, my stopwatch like that? Is if it continues like that, is it precise?
No.
Is it precise?
Yes.
Yes.
Okay, why did you say yes?
Because it will always produce the
Sir, because
result.
moving from
Is producing a consistent result. Is that not?
Is it, sir?
So it is precise. Is it accurate?
It might not be accurate, but it will
No.
give the same results.
Why did you say it's not accurate?
Is 1 hour faster?
Is it 1 hour or 5 minutes faster?
5 minutes faster.
5 minutes
So
faster.
Sorry,
it's
5
almost
minutes.
5 minutes faster. So if you look at the circles I gave you in this slide, you will discover that in the first circle, we have all those black dots. They are very close together. Do you notice that?
Yes, sir.
Yes, sir.
So they are very close together. That's precision. But they are far from the center. Are they far from the center or close to the center of the circle?
Far from the center.
They are far from the center.
So that means they are precise but not accurate. Because these things will help you to join your line of best fit. Maybe you finish plotting your graph and you want to join line of best fit. What I'm saying will help you to join your line of best fit. Now, if you look at the second diagram, those black dots are close together.
Continue, he has muted.
Okay. So in the second diagram, the black dots, are they close together or not?
They are close
They are
together.
not.
Again,
They are close
the answer
together.
again. At
They
the
are not
black
close
dot in the
together.
first one, now compare to the second one. The second one on my right hand, the black dot, are they close together?
Yes, they are.
Okay. Now, this is what I'm saying. Okay, I think this is better now. The black dots here, are they close together?
No, they are not close together.
Okay. The black
They're not
dots
close
here,
together.
are they close together?
They are close together, yes.
No,
They're close together.
So,
Yeah, they are close together.
so are they close together here?
Yes.
Yes, they are close together.
They're close together.
Okay. So who is that fellow? Okay, can we move on now? No,
Yes,
the
sir.
person has okay. All right, thank you. So now, if you look at this diagram, the black dots, they are close together. So that shows precision. But because they are far from the center of that circle, that shows that precise but not accurate. But in this other diagram, the black dots are close to the center, but they are not close to one another. So because they are close to the center, they are close to the true value. That shows accuracy, but they are not close. The values are not close. The dots, the black dots, are not concentrated at a point. So that shows that it is not precise. So the person is just trying to walk towards maybe an answer they told the person. Did you pick the difference?
Yes, sir.
Yes, sir.
Very good. So now I want you to plot a graph, but before I ask you to plot a graph, I want to make some revisions. Now, on the graph, what are the two basic axes that we have?
X and Y.
Y-axis and X-axis.
Vertical and the horizontal axis. Is that taken?
Yes, sir.
All right. Now, if they ask you, if they say IV characteristics, or they say velocity time graph, or they say displacement time graph. Are you with me? Or they say force extension graph. Are you with me?
Yes, sir.
Now, this quantity that comes first will be on the vertical axis. If they say IV characteristics or IV graph, I will be on the vertical current. If they say velocity time graph, V will be on the vertical axis, velocity. They say displacement time graph, displacement will be on the vertical axis. If they say force extension graph, force will be on the vertical axis. So that's how to name a graph. Shall I say that again?
No, sir.
No, sir.
The V, this T, this T, this X, they will all be on the horizontal axis. So that's very important, on the horizontal axis. So this is the vertical axis. You say IV characteristics. So this is the origin. So now, most times on a graph, we have the thin line and we have the thick line. These are the thin line, the thick lines. So we have thick horizontal lines and we have thick vertical lines. So all these ones I'm drawing are thick lines. Have you picked that?
Yes, sir.
Good. So most times the distance between two thick lines is either it is 1 cm or in some cases it is 2 cm, but generally it's supposed to be 1 cm. Did you pick that?
Yes, sir.
So for a graph,
No, sir.
the dimension of each box is supposed to be the same. The
No, sir.
dimension of a box is supposed to be the same.
Sir,
So this is
I didn't
A,
understand.
this is B. Okay. Did you understood what I meant by thick lines? Did you pick what I meant by thick lines?
Sir,
That's the challenge. When you ask question and I'm not
please,
getting, yes, I'm with you. I'm kissing
can you
now. Yeah.
explain again? I didn't understand.
Ah. Okay. Who had help her to vocalize what she said? If you add her, help her to, yes, help her to amplify what she said. Uh, hello.
So we didn't get that.
Hello.
Sir,
Okay,
we
you
didn't
didn't
hear
get
you.
her too.
Yes, sir. Can you? Yes, sir.
Okay, so can we move on now? Can we move on?
Yes, sir.
Yes, sir.
Yes, sir. So now, did you see my small a and small b?
Yes, sir.
Did you see?
Yes, sir.
So for every graph, for the grid, a and b must be equal. So a and b may be 1 cm, 1 cm, or 2 cm, 2 cm. Did you process what I just said?
Yes, sir.
Good. So these are the thick lines. Then now have thin line too. So in between them, the thin lines are usually 9, 9 or 5, depending on the type of graph you are given. But of course, I have to give a. Who is that fellow?
I'm not getting what you're saying.
Can you hear me now?
Yes, sir. We can hear you.
Yes. So someone says she's not getting it. Ask question. Yes. Is that
It
James?
was the mic this thing that was affected.
Yes, Jemezu, can you hear me now? Or who said she's not getting it?
I was the one. I was not hearing what you were saying at first.
Oh, can you hear now?
Yes, I can hear you now.
Did you understand? Did you understand what I meant by distance between two thick lines?
Yes, I did.
Because that is what will help you to state the scale you are using. To help you to state the scale you are using. Is that taken?
Yes, sir.
Very good. So we don't usually use arbitrary scales. Arbitrary scale is saying 1 centimeter represents 3 volts. No, we don't do that. So we usually use 1, 5, 10. So those are the values 1, 2, 5, 10 most times. 1 centimeter represents 1 ampere, 2 centimeter represents 2 volts. So those are the things, those are the values you should try to keep to. Is that it?
Excuse me, sir.
Yes, brother.
What numbers that are in decimal? Can we not use 0.1 or 0.2 as the case may be?
Very good. As the case may be, try to stick to 0.1, 0.2. Don't use 0.3. Don't say 0.7. 1 centimeter represents 0.7. Try to avoid those arbitrary numbers. 0.1 is okay. 1 centimeter represents 0.1 and seconds. 1 centimeter represents 0.2 seconds or 0.2 ammeter or 0.2 meters or 2.2 cm. So try to keep to 1, 2, 5, 10. Is that taken?
Taking, sir.
Very good. Thank you, brother. So now let's say you have an IV characteristics like this. We have I. This is the origin. This is the origin. Then we have the V. Then you now plot your graph. You have something like this. So from here, if they ask you to calculate the gradient of the slope, so how will you go about it? How do you calculate gradient? Yes, anyone? How do you calculate gradient?
Change the vertical.
So is that y2 minus y1 over x2 minus x1?
Yes, but in this case, we don't have y, we don't have x. So we need to use what we have. What do we
Oh,
have in this case?
I2, right? Minus I1 over V2 minus V1.
Very good. Very good. Now, don't go and pick small portion like this. It's not acceptable. So make sure you pick large enough portion that will show that your line is a straight line. So you trace this here, you trace this here. So this is I2, this is I1. Whatever value, yeah, whatever value is here is what we record as I1. Whatever value that is here is what we record as I2. Who didn't pick that?
Go on, sir.
Sir, repeat
Okay.
what you just said.
Now, don't use small triangle like this to calculate your gradient or slope. Make sure it covers about half. of your slope. So that's why I redraw this. Did you pick that?
Yes,
Is
sir.
that better? Okay. Now, after drawing your triangle like this, you will trace this portion to the I-axis. So whatever value is here, that's your I2. Did you pick that?
Yes, sir.
Sir, are we really going to draw these broken lines in our books?
Yes, you are permitted to draw broken lines, but use your meter rule, use your ruler, your 30 cm. Is that taken?
Yes, sir. Thank you, sir.
That's I2. Now, don't make mistake of not picking IV1 where you picked I1. So this is I1. This is where you picked I1. So you also pick V1 from here. So V1 will be here. This is V1. You picked I2 from here. So this will be V2. Who didn't get that? Let me use another ink. This point, you trace this point to vertical axis to pick I2. So it is that same point that you will trace. It is that same point that you trace the horizontal axis to pick V2. Is that taken?
Yes, sir.
Very good. Now, this second point, you trace it to vertical axis to pick your I1. Is that same point you will trace to the horizontal axis to pick your V1. If you misinterpret it, your answer will carry a negative sign. If it's supposed to be positive, mainly you misinterpret it, you will get a negative answer. Is that taken?
Yes, sir.
Okay, can we move on?
Yes, sir, we can.
Thank you. Now, this type of graph will give you a positive gradient. The slope in this case will be positive. But if your graph, after plotting it, looks like this, IV, something like this will give you a negative gradient. By the time you calculate the gradient for something like this, your answer will be negative because as V is increasing, I is decreasing. So this one will give you negative gradient. Why this first one, as I is increasing, V is also increasing. So that one will give you a positive gradient. Who didn't get that?
So I didn't get that.
I didn't, sir.
Okay. Okay. So let's say this is 0, 1, 2. This is 1. This is 2. Are you with me?
Yes, sir.
Yes,
As
Yes,
sir.
sir.
V is increasing 0 to 2, to 2 to 3, high. What's happening to high? As V is increasing from 0 to 3, this is V. What's happening to high?
I is reducing.
Decreasing.
Is that?
So why then will you not have a negative value?
Very good. Very good. Now, are you there? That's a good question, but are you there?
Yes, sir.
So the gradient is still I2 minus I1 over V2 minus V1. Is that taken?
Yes, sir.
So my I2, I pick it from here. So let me say this is 2. So let me use 4 here. This is 4. So this is 3. So my I2 is what?
3.
3.
3.
3. So that's 3 over. So this is where I picked. This is where I picked I2. So I will also pick V2 2 from that same point. So what is V2?
One.
One. What is that?
Sir,
Uh-huh.
shouldn't
So if I pick,
three
what did you say?
shouldn't V2 be three?
Well, do you notice that this is the point where I put I2? Ah, alright, are you still
So,
there?
but I think that V is increasing from 1 to 3. So 3 should be V2
That's why I'm explaining that if you do it that way, you will mix it up. Are you there?
then. Sir, someone's mic is on.
Hmm. Okay, can we move on now?
Yes, sir.
Now, did you see my red ink? Did you
Yes,
see the
sir.
red ink? If you trace that red ink to the vertical axis, what value is there?
1. No, sorry, it's 3.
So that's where I got my I2. So to get V2, you will trace that red point to horizontal axis. So what's there?
1.
So that's how to get your values. Now, I want to get my high one. So the second, can you see the red circle now?
Yes, sir.
If you trace it to vertical axis, what is there?
1.
If you trace it to horizontal axis, what is there?
2.5.
So let's say 2. Is that not?
Yes, sir.
So what's 3 minus 1?
2.
So what is 1 minus 2?
Minus 1.
Minus 1.
So what's the final answer?
Minus 2.
Minus 2.
So anytime you see a graph like this, it has a negative gradient. Hello? Okay. So anytime you see a graph like this, it has a negative gradient. But if it is like this, it has a positive gradient. Did you pick that?
Yes, sir.
Yes, sir.
Now, the general equation for a straight line is such that y is equals to mx plus c. That's the general equation of a straight line. Are you with me?
Yes, sir.
So y is the dependent variable. That's the variable you plot on the vertical axis. Should I say that again?
Yes,
Yes,
sir.
Y is the dependent variable. That's the quantity or the variable that you plot on the vertical axis. Shall I say that again?
No, sir.
So if you look at this graph, what's on the vertical axis? What's the dependent variable in this graph now?
I.
I. Very good. So I is the dependent variable. So M stands for what? M stands for what? M stands for gradient or slope. M stands for gradient
Gradient.
or slope. So have we calculated gradient or slope today? Okay, can we move on now?
Yes,
yes,
sir.
Can we move on now?
Yes, sir.
Yes, sir.
Um,
Yes, sir,
so
we can.
have you explained how to calculate gradient or slope today? Ah,
So I didn't hear what you said.
have you have I explained how to calculate gradient or slope of a graph? Have I explained it?
Yes, sir.
Yes, sir.
So what's the formula?
Y2 minus Y1 over X2 minus X1.
Okay, thank you. So now the next one is the x. So x is the independent variable. That's the variable on the horizontal axis. X is the dependent variable, is the variable on the horizontal axis. Is that taken?
Yes, sir.
Yes, sir.
Now, C is the intercept on y-axis. So now, if you look at this graph, okay, this one, can you see the graph? I'm using blue ink to box. Have you seen that? Good. So this line is the slope. So that line crosses the vertical axis at what point? At what point does that line cross the vertical axis?
At 0.
At 0. So for this, the intercept is 0. Should I say that again?
No, sir.
Okay. Now, for this graph now, I want you to tell me the intercept for this one. What's the intercept for this graph? What's the intercept for this one? What's the intercept?
3.
The intercept is
There
what?
is no intersection.
Something above 3 or 3.1.
What's the intercept for this second graph?
So the
3, sir.
impact is it on the horizontal or the vertical?
Intercept generally is on vertical axis, except otherwise stated. Except they tell you specifically that you should look for intercept on horizontal axis. Because for that equation, for the equation to be homogeneous, of course, that should be on vertical axis. So general intercept is where your slope crosses the vertical axis. Have I answered that?
Yes, sir.
Yes, sir.
So for this graph now, where is what's the intercept?
3.
It's 3, sir.
Okay, so that will be like 3 ampere. So let me give you one more thing on that. I want you to tell me the intercept.
Yes, sir.
All right. So I want you to tell me the intercept for this graph 0, 0, 2, 3. So for this graph, what's the intercept?
2.
The intercept one more. So,
3.
so something like this. Origin R 2, 3 minus 1 minus 2. So we have something like this. So for this graph, what's the intercept?
Minus 1.
Intercept. So now we've come to the point of exercise. We've come to the point of exercise now. So okay. Yes, someone should read for us. Yes, who's reading? Not so well.
Table 1.1 shows the results of an experiment to measure the resistance of a carbon resistor whose resistance is given by the manufacturer as 47 plus plus or minus 3%.
Number 1. Table 1.1 shows the results of an experiment to measure the resistance of a carbon resistor whose resistance is given by the manufacturer as 47 ohms plus or minus 10%. A. Plot a graph to show the IV characteristics of this resistor. B. Do the points appear to fall on a straight line that passes through the origin of the graphs? C. Use the graph to determine the resistance of the resistor. D. Does the value of the resistance fall within the range given by the manufacturer?
Very good. Thank you for reading well. So now we have on this table now we have potential difference measured in volts. Then we have current measured in ampere. So when the potential difference is 2.1 volt, the current is 0.040 ampere. When the potential difference is 4.0 volt, the current is 0.079 ampere. When the potential difference is 6.3 volt, the current is 0.128 ampere. When the potential difference is 7.9 volt, the current is 0.192 ampere. When the potential difference is 10.0 volt, the current is 0.202 ampere. And when the potential difference is 12.1 volt, the current is 0.250 ampere. Is that taken?
Yes, sir.
Now, how many of you have a graph sheet or graph book with you and a pencil and ruler?
I do, sir.
Sir, give us time to bring it now.
Okay. Now, that brother said, I do. How many vertical thick lines do you have? How many vertical thick lines do you have? Is that brother still there?
Mine is 15.
Yours is vertical thick lines. Yours is how many?
Sir, do you mean on the vertical side?
No, vertical. This you see, this is vertical thick lines. These lines. That's what I want you to count. But okay, count the margins too. So this is margin. This line is margin. This line is margin. So if you count the margins, 1, 2,
15.
3, 4, 5,
11.
6, 7. So for someone is 11, for another is 15. Did you say 15? Sister, did you say 15? Hey, is she still there?
She said 50.
Okay. Now, so the next one is to count horizontal lines. So how many horizontal lines do you have? These are horizontal lines. Horizontal thick lines. Horizontal thick lines. These are horizontal thick lines. So this is
12.
margin. This is margin. 12. Very good. 1, 2, 3, 4, 5, 6, 7, 8. Is that taken?
Yes, sir.
Can we move on?
Yes, sir.
All right.
Yes.
Now, looking at our table of values, do we have any negative values?
No,
No,
sir.
sir.
So that's a very
No,
good
sir.
one. Number one. Number two, what type of graph did they ask us to plot? That's in alphabet. A. What type of
I
graph? IV. So
I
what
against
I
quantity will
against
be
B.
go? So which of the quantity will be on the vertical?
I.
I
I.
I.
Which of them?
V.
Very good. Now, since we don't have any negative value, so what to do is that you can easily rule. Don't rule on margin. Don't rule on margin. So this axis is the I axis. I measured in ampere. Did you see how I wrote mine? So is that how you write I measured in ampere, or you say I measured in ampere? You can use any of the two notations. It stands for current measured in ampere. Is that taken?
Yes, sir.
yes, sir.
Can we move on now?
Yes, sir.
Good. So the horizontal axis, you can easily rule here. Don't rule on the margin. So this is V measured in volt. That's the horizontal axis. This is the origin. This is the origin. Did you pick that?
Yes, sir.
Yes, sir.
Good. Now, let's now pick
Can't we use 10 in the middle to
yes,
identify the origin?
one zero in the middle like this. Yes, is allowed.
Yes, sir.
Okay. So can we move on now?
Yes, sir.
Now,
Yes, sir.
when you say for I, what's the highest value for
0.250.
for the current? What's 0.250? What's the least value? What's the least value for I?
0.040.
0.04.
0.04. So what scale do you think will be suitable depending on the number of lines we have on our vertical axis, on the horizon, the number of horizontal lines that we have? We have 0.04 to 0.25. So what do you think will be the most appropriate scale on the vertical axis?
0.1.
0.2.
0.1.
No, that's not a scale. The
0.5.
scale
0.5 or 0.2.
0. Yes, on vertical axis. Okay, so let's do it like this. So screenshot
0.2.
0.2. Okay, screenshot this page. I want you to plot the graph and send it to the admin. At least you are not too much, so I can go through all your. This is not too much, so I can go through all your work before the next class. So screenshot the question, plot the graph, answer the questions. So it should not be more than 2 pages. One page is your grid, the graph. Then the other page is okay. Even the slope, you can do it on the graph too. Then the details, okay, you can write them on the next page. So you submit that by tomorrow morning to the admin. Admin will send them to me. Who didn't get what I asked you to do?
Move on, sir.
Yes, brother, I'm with you. What did you say?
I said move on.
We should move on. I didn't hear you. I didn't hear him. Okay. Any other question or contribution before we call it a day?
No, sir.
Oh, no.
Yes, sir. I have a question.
Again,
I have a question.
okay, please ask.
My question is, in the exam, yeah, question, answer, practical questions will be given to us. The way I can manipulate the table without doing the practical, since I will not provide for the answer apparatus for this question.
No, there is no way you can manipulate without doing the practical. At least you must guess 2 or 3 values correctly before you can manipulate. If not, the examiner will check precision. So when you are guessing values, if they are so close, they could be out of accuracy, and that may be a total loss of 25 marks. If you guess and your answer is close to the true value, it may not have accuracy and it may not have precision. So by the time you are plotting your graph will not give a straight line if it's supposed to give a straight line. So the examiner will have known that it's either you were told something and you are trying to walk towards instead of plotting the graph, instead of doing the experiment. So those are the major 2 loopholes that if care is not taken, if a kind missing out of practical is a big thing. So you can't manipulate using formulas and derivations without getting 2 or 3 set of values, corresponding set of values. If you are sure of the 2 or 3 set of values you've gotten, with that, if they ask to do it 5 times and you do it 3 times, there is a way to manipulate and get the remaining values. Did that answer your question? Is it still there? I can't hear him. Okay, so we'll continue from there.
Sir,
All
please,
right.
are we to send our work on the practical group or must it be to the director herself?
If you send it to practical group, I'm not on the practical group. Did you get my point?
Yes, sir.
In the practical group, there is no way I'll be able to access it, except you tell the admin to send them to me after submitting to your practical group, or you send to the admin directly, put it physics practical assignment, so that they will know that I'm the one who gave you the assignment. They will be able to direct it to my wall. Have I answered your question?
Yes, sir. Thank you, sir. Good night, sir.
So in our next class, I will do more explanations, and I will try as much as possible to show you more components, how to connect and stuff like that. Then we'll try and do more of mechanics in our next class, or we do more of weights and light, rectangular prism, and the rest. So by the time we do it like that, and we should be able to cover some ground. Then I'll try as much as possible, God helping me, to be more practical. Yes. Then if I need to show you videos, I'll also show you videos for you to be well familiarized with what I'm saying. So thank you for your attention, contribution. I'm really excited. God bless you. Okay. Good night.
Thank you, sir. Good night, sir.
Thank you too.